Up to also. 11. Okay. 13. 13, okay. Sure. Let's take a look at question 6. Could I clarify question 6, which part is the issue? Part 1. Oh, okay. Quickly come in. Okay, let's take a look at question 6, part I. We want to find out the coordinates of P when we're given this information. Okay, what will you start off with first? Wait, now what do you start it off with? What do you try? Sub the point. Sub which point? This point. Okay, so to find out the y coordinates, okay? So you can find out the y coordinates D and E by putting it into this equation because the question says that these 2 points lie on this equation. Okay, so at x equals to 1, your y would be minus 5, minus 4, minus 10. Okay, so A is 1, negative 10. Then at x equals to 5 would be negative 6. So B is 5, negative 6. Okay, so after knowing your coordinates for A and B, at least you now have numerical values that you could work with. Since the question says that the tangent, okay, is parallel to this, okay, so we can find out the gradient of AB. So this is 4 over 4, it's 1. It's 10. Okay, so gradient of AB would be 1. So that means the gradient of tangent is also equals to 1. Okay, since we want to find out the coordinates of point P, okay, what we can also do to help us to find the gradient of this tangent is to differentiate the curve function itself. Okay, so if we were to differentiate this, I will have the expression 2x minus 5. And that will be the equation, the expression for all the gradients of all the tangents. Okay, so we are now looking at the tangent where the gradient is 1. So 2x minus 5 is equals to 1. So we find that the point where the gradient is going to be 1 is at x equals to 3. So when x equals to 3, we will find the y coordinate that will be 9 minus 15, that is negative 6, negative 12. Am I right? Is it 9 minus 15 is negative 6 minus 12? Yeah. Okay, so the point P is 3, negative 12. Okay, questions? Do I need to do part 2 and 3, Chloe? No need? Okay, great. Next, we look at question 10. Gradient of the normal to the curve. Okay, may I know what is the gradient for part I that you got, Joseph? 10 part I? 1/4. Normal, because part I asks you to find the gradient of the normal, right? That is 1/4. You agree with this gradient that we get for part I? Okay, so I'll jump into part 2. Question wants you to find the angle, this normal to the curve mixed with the x-axis. So if you recall back to our chapter 6, the one on your coordinate geometry in AMATS, okay? I forgot, is it chapter 6 or 8? Okay. Okay, in that chapter, when I introduced to you gradient, okay, we talked about gradient being equals to tangent theta. Do you remember that? Okay, why is it that the gradient is equals to tangent theta? Is that if you recall a straight line, okay, we are looking at this angle here, okay, which we call theta, and this angle is made to the positive x-axis. Okay, and if you were to investigate from a right angle triangle point of view, okay, opposite will be this side, adjacent will be this side, okay, and consistent with our idea of rise over run, okay, rise will be our opposite, run will be our adjacent, so opposite over adjacent is equals to our tangent theta. Okay, recall that? So, therefore, using this concept, okay, to find out the angle that we want to find, we would be taking tangent theta equals to 1/4. So, tangent inverse of 1/4, and you would get 1/4. 14.036 degrees, and that will be 14.0 degrees, 1 decimal place. Okay. Any questions? May I know what's the concern for question 11? Is it right from the start? For question 11? May I know? Who asked for question 11? Okay. Okay, every time I ask this kind of question, then after nobody tell me. I'm very sure I saw hands, come on. What's the issue with question 11? Right from the start, is it? Okay, okay, I saw a lot, alright? So, let's do it right from the start. Okay, we want to show that the coordinates of P in part I, and P has the coordinate 0, -9. Okay, let's try to draw this out. Okay, quadratic, negative, so maybe this shape. Okay, then normal at P is perpendicular to 2y minus 6x equals to 10. Let me draw a better shape. Okay, so this would be, let's say, the line is this, normal is, okay. So we got a line 2y minus 6x equals to 10. So let's say maybe this is the line. Okay, then there is a point P and that normal at P is perpendicular to this line. So let's say if my P is here, okay, this would be the normal, alright? And what this says about the normal to this line here, okay, is that the tangent itself will be parallel. Okay, so this is the tangent at P. Well, this is the normal at P. Okay, so this tangent at P will be parallel to this line because the question says that the normal at P is perpendicular to this line, right? So I'm trying to derive all the information that we could get first. Okay, so now we want to show that this point has these coordinates. So it's somewhat similar to how we did in question 6. Okay, question 6 we have to go about deriving the gradient of AB. In this case, we can get the gradient, okay, of the tangent based on this straight line equation itself. So 2y minus 6x equals to 10. 2y is equals to 6x plus 10. And y is equals to 3x plus 5. So the gradient of this line is the same as the gradient of the tangent. So gradient of tangent at P equals to 3. Okay? Does anyone not understand what I'm trying to work with over here? Alright? So likewise to how we did in question 6. Okay, we got the curve here, we got the equation. I can differentiate this equation to find out, okay, the gradient of all the tangents, and then I can equate that with 3. So we find that the coordinates of P will be 0. So y would then be 0 squared plus 3, 0, minus 9, that's negative 9. So we have shown that the coordinates of P will be at 0, negative 9. Then in part 2, we want to find the equation of the normal. Okay, so will you now be able to find part 2, to find the equation of normal to the curve at P? Shamin, you think you can find part 2? Can? What about part 3? Will part 3 still be an issue? Which is to find the coordinates of Q where the tangent to the curve at Q is parallel to the normal in part 2. So parallel tangent at Q okay, so this line and this line is parallel. So you think can do? Shamin? So we got this gradient, can also use the derivative here, equate it to the gradient of the normal. Then you can find the point Q. Okay? Okay. Last one, question 13. Okay, question 13, may I know which part is the issue for question 13? Answer, I think you raise your hand, right? Question 13, which part? Part I? The whole thing? Okay, okay. So let's see part I, we want to find the coordinates of A. Okay. Since I've gone through questions 6 and 11 already, okay, maybe Anson, you could try part I, how to start to find the coordinates of A. Similar thing to what we did in question 11 and question 6. Oh, you did part I? Oh, okay. Well, what do you do for part I? Okay, find the derivative. So then what do you do with this derivative? Yes, okay, find the gradient of the tangent. So gradient of tangent at A is equals to the gradient of dB. So 11 minus 0 over 0 plus 2.2. So what is that? 11 divided by 2.2. Okay. Then what to do? Okay, 2x plus 7 equals to 5. So x is equals to negative 1. And then we can find y, right? One minus 7, negative 6, negative 6 plus 12, 6. So A is negative 1, 6. Okay? Next, part 2. The normal to the curve at A meets the x-axis at C. So this is the normal AC. So down here is perpendicular. We want to find the coordinates of C. Now that we have the coordinates of A, which is negative 1, 6. Okay, C is found on the x-axis. So this point would have y to be equals to 0. X is something we need to find. Okay, I have the gradient of the tangent at A. So this one gradient is 5. And that will tell us that the gradient of the normal here would be negative 1 over 5. Okay, so I can find the equation of AC. And then I can find the coordinates of C. So Okay, so at when y equals to 0, so x is equals to 29, therefore c is at 29, 0. Okay? Do I need to do the area of triangle ABC? What do you think? Do you need me to do the area of triangle? Hanson? Half times base times height. Can do? Okay, you try out. Alright? So then I'll just stop here. Okay, any other questions? Otherwise, could you submit your homework to the front? Number executive. That the last lesson we stopped at exercise 13.2, question 7. I didn't do part 2, right? Is it? Yeah, but I didn't go through, right? Okay. Permanent marker ink. Oh no! I can't erase it. Use whiteboard marker. I don't think it works. Oh, it works. Chapter 13.2. Okay, last lesson we talked about increasing and decreasing functions. Okay, could someone just tell me, alright, what is it that will tell us that it is going to be increasing function? What must we do to prove that something is increasing? Yes, Amanda? More than 0, right? Okay, so your dy over dx is more than 0. Okay, and decreasing function would be less than 0. Okay, when we go into the next chapter, then we talk about what happens when the derivative is equals to 0. Okay, so let's look at exercise 13.2, question 7, part 2. the last lesson, we were looking at this function and we spent time in trying to get the derivative, and we could simplify it into 3x minus 7 over 2x minus 1 to the power of 3 over 2. Okay, in part 2, we want to look at what is the range of values of x for which y is actually decreasing. So to know that y is decreasing, right, okay, it is when your dy over dx need to be lesser than 0. Okay, so if we look at the dy over dx itself, in order for this derivative to be lesser than 0, okay, we can look at the case where this one is lesser than 0, this one is positive, or else this one is negative and this one is positive. Okay, because positive and negative, when they divide each other, then we get a negative function at the end, right? Okay, so there are two cases for dy over dx to be lesser than 0. It's either one of the numerator or denominator that is lesser than 0. But if you recall what we did in part I, we have agreed upon that 2x minus 1 to the power 3 over 2 itself is more than 0 for all real values of x. Okay. Okay, so this will always have to be more than 0. Hang on now. Actually, on hindsight, for all real values of x. Okay, sorry, on hindsight, right, I think it isn't right for me to say for all real values of x. 2x minus 1 more than, to the power of 3 over 2 more than 0. For all real values of x, put 1. Okay, sorry, on hindsight, maybe I'll change my statement a bit. Okay, I think in part I also said that this one must be more than 0, okay, for all real values of x. It just struck me that it can't be the case, because if I have something that is, let's say, negative 1000, then this thing will not be defined, right? Okay, you understand? If let's say x is negative 1000, then it's negative 2000 minus 1, then it's negative 2001. But negative 2001 is not going to be a defined value, because when I take square root, I cannot take square root of negative 2001. You understand what I'm saying? Okay, so correct? Okay, so I cannot say that square root negative 2001, and then I cube it. Because this is undefined, alright? At this point here. So it is not true to say that this is more than 0 for all values of x. Because at some values of x, it's not going to be defined in the first place. You understand what I'm saying? Okay. So therefore, to correct my statement, okay, I should say that since this one more than 0 to be defined, I think that will be better. Okay, but essentially I just need you to get the idea that this thing itself must be positive. Okay. Okay, so therefore 3x minus 7 lesser than 0 and 2x minus 1 to the power of 3 over 2 more than 0 should be what we're looking at. And 3x lesser than 7 here. And we see that x has to be lesser than 7 over 3 or more than half. So, looking at the number line, more than half, less than 7/3. We get this overlap here. For y to be increasing. Any questions for that? Alright, then let's look at question 10. We are given a cubic function y equals to 4x cubed plus 4px squared plus 16x minus 9. We want to find the range of p such that y is an increasing function. Okay, so we stick to the information that we know that for increasing function to happen, derivative has to be more than 0. So we find the first derivative. Okay, we find that our derivative would be 16x squared plus 8px plus 16. Okay. So for y to be an increasing function, our 12x squared plus 8px plus 16 must be more than 0. And at this stage, it poses us a problem because we want to find the range of p. Okay, so how? Any suggestions from anyone? How can I find the range of p if I'm actually having this? So something very different from what we were doing earlier, whereby we have a derivative like that, okay, and I could break it down to know whether the numerator or denominator is positive or negative. In this case, it's not possible, okay, for me to think about it term by term, because there are 3 terms. There are many combinations that could allow us to see that it's going to be positive, because it will have to be a case of being more than or lesser than to each other. It is a comparison to each other, and that isn't a very efficient method to do. Okay, so what could we do? Rina, can you please wake up? Okay, so what could we do? My hint here is that this is a quadratic function, and we're looking at a quadratic being more than 0. Does this ring a bell to anyone? Sorry? Discriminant, very good. Okay, so what about the discriminant? Yes, b squared minus 4ac. Okay, that's a good start. We will look at discriminant, but what exactly about the discriminant? What about the b squared minus 4ac? Should it be more or less equals to 0? Okay, so let's rephrase it. Instead of understanding this thing as resulting to an increasing function, okay, let's rephrase this one as having the idea of a quadratic function. always positive. Okay, so some quadratic function being always positive because more than 0 1. So if I rephrase it in that, does it ring a louder bell? I don't know if that is such an expression. Always positive. More than 0 right? Always positive. So what do we say about a quadratic function being always positive? Will it always be above the x-axis? Always above, always above, right? So diagram-wise, we think of this, right? Huh? Correct? And it must be this shape also, right? Because 12x squared, our coefficient of x squared is positive. So must be this shape. There might be an intersection of the y-axis, but that's not the concern here. Okay, so what if it is always above the x-axis? What does the discriminant actually tell us? Whether it intersects the x-axis or not, right? Okay, so the discriminant has always been a judge to us, okay, or a measure for us to know whether it intersects or not on the x-axis. Okay, so there are three different possibilities. More than 0, less than 0 equals to 0, right? Okay, when we say that the discriminant is more than 0, okay, how many intersections are there on the x-axis? There will be how many? 1, 2? You said 2, huh? Okay, there are 2, right? Because if you have forgotten all of that, we go even back to our formula. Okay, discriminant is found in our x formula. If the thing found inside the square root is positive, that means that I can have plus minus 2 different numbers. Okay, or rather I can plus, not say 2 different numbers, I can plus one number minus another number. I'm going to get 2 cases out for my x value. So there should be 2 intersection. So 2 intersection on the x-axis. And when we say equals to 0, the number inside the square root is 0. So I will end up plus 0 or minus 0. Regardless of which case, I will only have one answer for x, so there is one intersection. And when we say less than 0, how many intersections are there? How many intersections lesser than 0? Zhen Xuan? If I have lesser than 0, discriminant inside the square root lesser than 0, how many intersections are there on the x-axis? 0 intersection, right? Okay. Going back to our discussion, we agreed that our graph for this question looks like this. Always positive, shouldn't have any intersection with the x-axis. So our discriminant will be lesser than 0. Okay? You understand? So discriminant lesser than 0 will be the approach for us to figure out the value of p. Okay? So our discriminant in this case will be 8p squared minus 4, 12c. That gives us 64p squared minus away 768. Okay. So our 64p squared minus 768 will have to be lesser than 0. And okay, because we're talking about always positive, if we recall, there are 2 conditions when it comes to always positive. Not only the discriminant, but the coefficient of x squared must be positive as well. Okay, which is 12 more than 0. Because Okay, I cannot have a negative coefficient x squared which results in this shape and have it always positive, because I can always, my graph always goes infinitely. Okay, so I can never have such a case of negative coefficient and yet always positive. So always positive must be coefficient of x squared more than 0 and b squared minus 4ac less than 0. Okay, I'm using this chance to for us to recap a bit of our chapter 1 and 2. Okay, any questions at this point? So now I have actually in fact gotten rid of the x, because when I talk about discriminant, I only look at the coefficients. So I only took out the at most the p, the x are left there. So then now I can actually go about solving this quadratic inequality. So how do I solve this quadratic inequality here? This one not an issue anymore. So it's just this part. Factorize. Factorize. What can I factorize? How? I can factorize out 64. Left with 12. Okay. I can get rid of the 64. Okay, so p squared minus 12 less than 0. Then how to factorize it? Why cannot factorize? Rina, can you please wake up?
I don't think the correct term is factorized.
The correct term is factorized.
Oh, the correct term.
You are right that we have to factorize, but how to factorize?
So I don't know.
Is inequality, yeah? Huh? Because it's inequality, but to solve it inequality, we must factorize, ma. How to factorize?
So is it a squared, right?
Yes, a squared minus b squared. So a squared minus b squared factorize to become a minus b plus times a plus b, right? Then you were saying b minus square root 12 and p plus square root 12. Okay? So we use our a square minus b square to factorize this. So we get p minus square root 12 times p plus square root 12.
So we can put the 12 over and then square.
You think?
Not square root.
So square root like that? Can man? Plus minus So it is lesser than positive square root 12 and also lesser than negative square root 12. You think that makes sense? Lesser than square root 12 and lesser than negative square root 12. Then might as well tell me lesser than negative square root 12. Cannot, okay? Because I mentioned square root is not an operation, okay? And this is a function, this is the inequality itself. You cannot square root both sides. Okay? You can plus both sides, minus both sides, times both sides, divide both sides. But you cannot do things like inverse of tangent or inverse of function or inverse like square root. Okay? So we cannot do that. Okay? So we must factorize. Then lesser than 0. So this is negative square root 12, this is square root 12. Lesser than will be here, because it's this segment here. So therefore, P must be in between of negative square root 12 and square root 12. So that will be the answer. copy. Mine is not for copy. They're not going to become for the copy machine. Okay? Shall we move on? Okay, so with that, right? Okay, we're done with chapter 13.2. So, homework.
Yes! No!
I really like your enthusiasm.
I get.
Let me work out something that will be manageable. Yeah, I know. Then, so what does that mean? Yeah, there are many ways I can interpret that.
That means you can give as much homework as you want.
Is that really what? But you all this time WA1, right? How is it that you all have WA every day here?
I know, right?
No, it's very.
Why is your English WA1 here?
So what do you mean why?
I don't know.
Is this what it is?
Oh, okay. I thought language always comes first, ma.
So language already comes out. Chinese already like over 2 weeks.
Oh. Okay. Can shift the Amex. Cannot. That one is fixed through the level already. I can't. Yeah. I give homework deadline around here. Can. So Wednesday or Thursday? Preference? Chinese lit people, you all want Amex homework deadline here or here? What's the Chinese lit people? Sing and Ying. Here or here? Thursday, okay, so I give homework for 13.2 due on Thursday. Okay. So homework exercise 13.2. That's not that one was Hitler one, right? Was it? It looks very familiar. Oh, that's a communist symbol, is it? I forgot. Okay. Homework is this due. That's what it says Thursday, right? Sorry. Thursday, that is 18th. What time did I come out just now? My lesson finished already.
Yeah.
What?
So surprised.
So you spend half the lesson going through.
Ay. Don't I always for every deadline? Okay, then I'll just end here today then. I thought I could still go into